7, when did I stop at P7? Have I tried the, I think I've tried the Mandelbrot, right? Mandelbrot test point combination. I'm not sure about the second part. Maybe we haven't covered all of it. But I did explain the traversal, right? This is how you traverse the limits. This is how you traverse the limits and it appears inside your web here as well. You can set the default Chevrolet type. Okay, this is the way you put it in the minutes, or you can write in your code just before you start your Chevrolet. Type when we set Chevrolet. Okay, if you don't specify what function you use, you will be using the default one you set. Otherwise, you can just apply it inside your pragma. Inside pragma, you can specify what type of scheduling that you want to use. There's no example. As you can see from here, you apply the schedule. Sorry, not that one. Yeah, this one. Maybe for the scheduling type, and then we put the static dynamic. Guided or whatever that you want. And then here's another example. With the chunk size 4, maybe you can try this. You can try this. Actually, this one produces the output inside. Where do I get that? I'll get it from here. Just in case I do. First, click on this, and bring it here, and then scroll down. There's the source code. Source code of all present example. Right, click on that, and then you bring it to here. It's good GitHub. Just copy this, and then paste it. Paste it here. Sorry, You create your own project. If you don't have, in my case I already have one. So I'm going to download from last week. And if you create your own new project now, please remember to enable the one key. Yes.
PCQE 那是你等下那一个在这里口啊。
Yeah, actually, this is the one I was talking about. If you want to save it, you move it. This one has a lot of history behind it. If you delete it, your space is much. I mean, the zip file is small because it contains a lot of garbage inside. Okay, what we want is only this project and also some others that is needed for your project to be able to successfully do it. Okay, you do not need that unless you want to keep the display. Okay? Whatever you have done before. Okay, but before we get to that, let's try this one first. Before we try this, let's try this program. Okay, just in case that you want to know how to create, here I have one file. Right? And sometimes you want to put it into separate files, right? I'm not sure whether you have learned this before. That's how you do it. You right click here, add new items, new file, you call it, okay, and then we can paste this. I just want to put it in a separate file because I don't want to mix. I just put it there. And of course here you see it calls quite a number of programs there. A number of this functions, right? Basically, it's all this function and all this workout function. So what I'm going to do next is to create another here, data file, add new items. The data file will be HTTP. So let's call it scheduling as well. HTTP. Sorry. One name. And then move it right inside here, put it to the data file. Okay, and then we can copy this whole thing inside and remove unnecessary things. Okay, I don't need this because I just need to hit the function code type. That's all. So here is to put all your function code type. And what is this one? This one. This one. I think this one we don't need this, but let's leave it there. We don't need this just. Oh sorry, we need answer. Okay, so just run it nicely. Good. And what else do I need? I need this vector. And string. Good. Do I need anything else? This. Maybe. Yeah, just leave it. Okay, so that is for the header file. Okay. And then this will be I can include here. If I want to include my scheduling HPP. Oh, sorry, because you have to look for your current folder, okay, so you have to use this. It's not standard. It's not a standard data. So it should be okay, so let's go. Like the morning, and then go to this. This is schedule.
这个很现在，这个现在啊，就是现在。对，第二个第二题，这个是然后走上
Main just now, right? So I have to remove this.
最下面有一个 link，
Take this, cut this, put it here.
有一个在慢慢改。
Now I have two main. So I have to put it here. Okay, and here I have to remove this. Now I have two mains. Okay, here I temporarily remove this because it says I cannot use auto with a 4. Okay,
然后追上来，算是这整个狗。这个 add new add new เรา scheduling สิครับ
No, sorry. I need to put this back because of the flow, right? Shouldn't make me any difference actually. Yeah. Try this program here. Create a new project for this, just to find out whether it's running properly. Let's create a new one. Let's go to the schedule. Okay. So. Copy this again. I just want to find out what is wrong because it's not good on the sheet. Might be something that's not good. So let's try this. But I need to enable this because I create a new project. Language. Let's switch to yes. Okay. Let's try this. Okay, try properly. Oh yeah, this one's still the same problem, right? Let's try Let's try this. It works. Okay. Okay, I create a new project rather than put in my own project. This is a separate project. Just to get around the problem that we solved just now. Maybe I accidentally delete something. That's why I cannot link properly. Okay, instead of going troubleshoot, we just use this as an example. If you run this, you see the result that we saw there. It shows to you how the code is executed and the way the code is executed. So what you need to do is just, except for the last two, for auto, I think there's something that is not supported anymore. It's complaining that when we use auto, we cannot use core. The error I was telling is that. Okay? So ignore the last one, which is this one, no, this last one, because it doesn't work. Okay? This will be the result. Okay, so you can see how actually it execute. The star that you see and the way they execute is quite clear from here. Okay, so dynamically means create dynamic. And then it will be 8, 8, 8. Okay, so this line here indicates that it is executing in the same phase. Okay, so it will run. And then this 8 here is going to run the other phase. Okay, because maybe you have a for loop. So this is the first iteration, this is the second iteration. Right? But this threads here is running in the first iteration and the second iteration. And this is a separate tracks. Okay, but then they are running in the same iteration. Okay, so this the same iteration, This one, there's no equation for this. And here, there's no equation for this, but there's an equation for this. Okay? So dynamic is more dynamic. As you can see, it's quite chaotic. But if you run using static, it's much clearer. Okay? You see the static one is much clearer. Okay, so here, these are 8, so you got 16 altogether. Right? And they run in the first iteration. Okay, this one run in parallel. This one also run in parallel. Right? But it's in the same iteration. So this is one iteration, this is another iteration. Okay, so that is how this scheduling works. Okay? So refer to this code. As you can see, this is how we do it. First we tell we need this whole block to be in OMP parallel. Okay, this whole block here is OMP parallel. And we create 4 tracks. And what are shared? This one are shared. Vectors are shared. Okay, and this n is also shared. Okay, we specify it that way. Okay, once we enter here, we know that it's going to run in parallel. How many threads is going to run here? 4. Because we specify that 4. Okay. And inside here, we mention OMP for loop. Okay. Why we use for loop? Because we want the OMP to help us deal with the multiple threads in order to solve this problem. Okay? So it's going to use guided, and chunk size is 8. So our chunk size is going to be 8 threads. Okay? Then you will execute this for loop in that way. Okay? You push this vector up. Sorry, actually it's not push back vector. It's using this vector here. And this is the element inside the vector. And OMP get track number is basically how many tracks that you have inside there. And then you push back something, then you push back this number. Okay? So basically you push the number inside this vectors and then you print it out. Okay? If you look at here, you print out the value. Print iteration. So the number that you put inside there is going to be used to print out this asterisk. That's why you see the asterisk. Okay? And then you see this space here because of the space that is needed here. So you print the asterisk and then you print the space. Okay? And how many asterisks that you print? It depends on what you put inside the vector. Okay, so basically you see that. Okay, you put in, you push back and you tell this I. This I is the number that you push into the vector. Basically it just means this. This is your vector. Okay? Push back means you push to the back here. Okay, you can push to the front, or you push to the back. Okay, if you push to the back, you can attach. Basically, just append. It means append a number. So let's say you got a number inside there, and your I, let's say, is 2. So you push to the back of this vector, put 2 behind it. Okay. And the vectors, we got many vectors, right? So basically, this is a vector, and then we have also a vector like this, something like that. Okay? So this vector, this is a vector. Inside here contains another vector. Okay, so you got another vector here. Okay, so you got a vector of vectors. Okay, so this is the vector here. And then when you access into this element actually is also a vector. Okay? And then you take that vector, you push this value. Okay? So get track number is basically get the ID, right? Okay, so you get the ID of the tracks. Okay, and that ID contains a vector. for that particular ID of track, and then you push back down. And then later on you use this number to print the asterisks which you see here. Okay? Alright, so that is how it is used. So you refer to this code here, on how to execute it. Okay, so you got schedule, which is a function that is used here. Function that is used here. And then this is the function that you created here. Okay, so now please, let's say schedule guided tick, right? So you put it there, schedule guided tick. Okay. And then this is what you print out. That's what is print out here. Okay, and here is fed into this schedule, and that is used to specify how many tasks that you have. This thing. And this is the function that you pass it. It's a you can see that it is actually a function pointer T, function pointer, and it calls, it passes the vector. There's a vector that you pass it, and then you specify the n. Okay, the n is passed in through this argument. Okay, so you pass in the vectors, and then you pass in the n. So this n is the one that you do in the for loop. Okay, how many for loops that you put inside. Okay, so here is how you start it, but you do not need it if you don't want to. You don't need to schedule it this way. That is basically just to run the program. In our case, what we are worried is only this keyword here. This one is default. So default, you will use the default one, so it's empty there. If you want to specify it, then you put schedule static, or schedule dynamic, or runtime, or whatever. Okay? So our concern is really this one. Okay, see how it is used, and then apply it in your code here, in this code. This one, project code, which is, this one. Okay, I'm going to remove this temporarily, this doesn't work at the moment. Disable this. You exclude from project here, exclude from project. Okay? You don't have to delete it, just exclude from project. Okay, and then this one is the whole program, right? So we need to do like this. So we got two projects. One project was, for example, which we used to refer to. And this one is the one that we're going to solve the problem. We run this. Okay, here will be the things it will compute for you. Okay, what you need to put in here is the one that I mentioned to you just now. Okay, you know that it's going to be OMP parallel. Okay, there's no forwards on it. Parallel. And then you refer to program just now, and then inside here, we change slightly, and then use OMP. Maybe you want to use OMP 4. If you use OMP 4, you cannot use one loop here. You have to change slightly then in order to use the 4. Okay, OMP 4. Then you can add pragma OMP 4, and then how you want to schedule it. Okay, so if you're able to schedule it nicely, then you see that as enter into the process work. Okay, each of the thread is going to assign the process to each of your track ID. Okay, and then you execute the program. Okay, now I'd like to try on your own first. This program. Okay, this program actually copied from here, just in case that you missed what I mentioned last week. You get it from here. Copy this whole thing. And then paste it here. Paste it here. Okay. Did I mention to you how this thing works last week? I did explain how this thing works, right? Did I? Did I explain how this process will function? Specify what is private. Okay, what is shared. Maybe you can put this. All shared. You can see here, the problem with the P. Maybe you need this private. So maybe you don't need private. In this case, I don't think you need private. You need to get the threads that actually execute, right? solve this problem. Because scheduling is just the schedule, but it does not show you how to solve this. Okay, there are many different ways to solve. Maybe we try a simple one first. Simple one first. Something that we have learned before. Okay, first what we need is we have this track that is going to traverse. Okay. And then here 1, 2, 3, 4, 5. There's about 5 of them. And the last one is continue. This one is head. Okay, so we're going to use track 0 to traverse this. Okay. And when it traverses all this, and then we have the data which we can use to place inside the vector. Okay, and each one of these element inside this vector will be processed by the respective threads. Okay, so we can use a vector. Of course, this one is linked list. We put this into a vector first. Okay, and this vector is shared, and we're going to access this vector to solve it. Okay, and we need a barrier here somewhere. Okay, because we need for the thread 0 to put all this into the vector first. Okay, and then we put a barrier. So what it means is place all elements in this into a vector. Okay, this is the simplest way to solve it. Put it in the vector. Alright. Then everybody must wait here. Okay? Wait at the barrier. And why do you need to wait? Because you need to wait for thread 0 to finish doing this first. Okay? Thread 0 places all elements or insert all elements. Okay, all elements into the link list into vector. Okay, wait at the barrier. Once everybody reach this point, including this thread number 0, then everybody will start to run at the same time. So each one of them, each thread, okay, gets its own thread ID. Okay. Use thread ID. Okay, to access the element inside the vector. Process. Okay. So basically, just calling this process will. Each one of them will call thread. Okay? So the idea is something similar like what you see in the exercise just now that prints the value. Okay? So we use vector as well. So we're going to share this vector. And how do you access this vector? Maybe here is, let's call it fibo or fit vector. Let's call it fit vector. Okay, and you do it this way. Okay, so fit vector ID. Okay, you return this. Okay, you return this. Alright, and then you can call. Okay, maybe it's a pointer pointing to it. You can call. Sorry, you don't have to, because you can just process on it, right? So you can just process on this. Just when you return the pointer, then just process. Process. Okay, process word. Instead of P here, so P, we're going to call 592 vector and then the ID of it. Okay? So what we are doing here is we use this linked list, okay, traverse in this linked list and build the vector. Okay, why we build this vector? Because each of the thread can access the element easily using the ID. Here is very hard because it has no ID, right? So you got a problem there. So I suggest that thread 0 convert it into this vector and then process it. So this one way, the first way. This way. Okay? How about the second way? I think the second way is the way that this function is, this program is trying to use. Okay, second way. Okay, the second way, you don't create a vector. Okay, everybody will enter into this linked list. Everybody will enter into the linked list. Okay, so thread 0 is going to grab the first one. Thread 1 is going to grab the second one. Okay, thread 2 will grab this, thread 3 will grab this, and thread 4 will grab this. Okay, so how do we do that? We have to change slightly this program. Instead of while loop there, maybe we use for loop. For loop. I start from 0, then I less than the ID. Less than the ID. Once you reach the ID, then you know already that you have to stop. Okay? Okay, so ID 0, the first time you already stop. This is the one that you have to fit it into this process mode. Okay? Now if let's say your ID is 1, so this for loop is going to be 1 there. Okay, first you start here and then you have the next iteration, you go to the next. You go to the next will be this one. Right? Then you stop. Because only 1, right? You stop, then you get out, and then you take this process, put it into process mode, call process mode and pass in this value. Okay? And the third ID comes in, let's say ID 2. So here will be 2, right? So this for loop is going to be two times. So the first time you go into here, the second time you go into there. Right? And then when you stop, right now your P is pointing there. Okay, so you pass it into this process mode P. Okay, so that's the second way. Second way, you do not need this vector. You just enter into, each one of them will enter into this linked list. And then they will travel inside this linked list and try to find its own element to execute. Okay, so you can use first way or second way, it's up to you. Now first way, only thread 0 is going to do this job. Okay, only thread 0 is going to insert all the elements into the vector so that they can use this vector easily by referring to the ID, and then they can access, randomly access. Okay, if you want to access this linked list individually, then you use the second way. Okay, so each one of the thread is going to enter into this linked list. Okay, thread 0 is going to stop here, thread 1 is going to stop here, thread 2 is going to stop here, thread 3 is going to stop here, thread 4 is going to stop here. Okay, so as you go in, and then they grab their own respective value. How about other threads? Okay, if other threads, you have to put another condition there. If let's say you already reach now, okay, then the other thread should just don't do anything. So the process works, so there's a condition there. This is the first step. The second step is there's a condition. If P is now, not now, sorry, then only process go. Okay? Because you might have more than more threads than what you have there. Maybe you start 8 threads, for example, right? Or 16 threads by default. So the first 5 threads is going to execute it. But the 5th thread, when it comes in, you will get to this. See that its P is null, and therefore you will stop. Okay, you will stop it. That means it does not execute this process word because P is null, so you skip. Okay? Any other thread will skip except for the first 5 threads. The first 5 threads is going to grab their own respective data to be processed. Is that there? Okay? You want to try the second way. The first way you use vector might be a little bit challenging because you need to use vector. If you do not know how to use vector, then you got a problem there. But if you don't want to use this, I suggest you use the second way. Okay? The second way you just use for loop and then you find your ID, and each one of them going to enter into this linked list using this similar technique like this, except that we don't use while loop, we use for loop. Okay? And then as an access, you enter into this variable, sorry, this linked list, and then you stop according to the ID that you have there. Okay? And of course here there's another condition, not only one condition. You have to stop also when P is 0. Okay? So it's either this and P is not 0, not now. Okay? And then I plus plus. Okay, so that's how we do it. Okay? So the ID needs to be less than that, and then P is not now. If P is now, then you need to stop. When you stop, if P is now, you will skip. If P is not now, you will process it. Okay? So by doing this, then you can create as many threads as you like. But of course, the most efficient one of the thread is 4. That's like 5 in our case. But even though you accidentally put more than 5, your code is not going to hang or will not crash because of this condition that you put in. Okay, first you will look until there's nothing more. Okay, or you will look, but then you reach this point where you can grab the element, and when you get out from this loop, because it's not now, it's going to pass the process word. Okay, so that particular ID is going to execute it. Right? Okay, this one you don't need to create a vector. But every thread needs to enter into this linked list in order to grab the corresponding element. Okay? If you use the first way, thread 0 is going to convert this linked list into vector first, so that you can easily access the element using this technique. Okay? So this one is much more straightforward. Okay? Only thread 0 is going to access into the linked list. Here, everybody needs to access into the linked list. Right? Here it looks a little bit shorter, but I think it's more or less the same. Okay, and then here you don't need to wait. Here you have to wait. Here you have to wait for thread 0 to complete. Here everybody can start at the same time. Alright? Okay, you try this way, and then let me know if you succeeded. Anyway. Okay, if you want to create a vector, I suggest that you create this way. Okay, one thing. This ID. while loop, use for loop. Or maybe you can use while loop as well. While loop as well. Okay, and then here you need to share this Fibonacci. You need to share you share the vector. So this vector. Okay, when you put vector up here, you have to import vector. Vector. So it has vector there. Here is the vector. Create the vector, okay, and the type is struct. This is the type that you need to put in here. Okay, and that's called vector. That's called big vector. Okay. Okay, there's a problem here. Oh yeah, so right now it disappeared. So standard vector, and here is a type, and then fit vector. Yeah. So then you push back. With push back. Maybe I'll show you. So I'll show you the first part. I'll show you this part here, and the rest you do as well. Okay? Push back. Push back. P. Okay, if you don't know what push back means, you can always go and search. Okay? Vector push back. C++. This is how we probably do it. So you get the value and then get push back. And it does not show you how to maybe represent for example. Okay, the input, push back, then the output should be something. So when you push into this my vector, 6 will be added. So if your my vector is this, you push 0, push at the back. Okay? So this is the first element, and you can access that element using your own ID. Okay? Access. Okay. So I already done this part here. So this one only ID 0. Track 0. Do track 0 to perform. Okay, else? Oh, sorry, there's no else. Everybody, including track ID, is going to process this. Okay, do process it. Oh, sorry, you have to wait first. Wait for the barrier. Wait for track 0 to complete. Okay, everybody needs to wait here. Okay, next. Next is each track gets its own ID. It's already done here. Everybody gets its own ID. Okay. In this one, only track 0 is going to perform this task. Okay. Wait at the barrier. We're going to fill in a blank pad. Okay, so this step already done for you. You just need to do this, and then you need to do the last. Okay. each thread. The process. Okay. Based on this idea. Okay, so here is what you need to do there. Okay, so you're going to call process work and pass in the element inside this Fibonacci vector based on its own ID. Okay, so basically what it does here is this vector is going to have pointers. So this one is going to point here, this one is going to point here, this one is going to point here, this one is going to point there, this one is going to point here. Therefore, star 1. Okay? So this Fibonacci vector, so this is the linked list. Thread 0 is going to create this Fibonacci vector and then let each of these element here points to the respective element inside this linked list. Okay, and then now when you're here, you're supposed to call this process work, and then each ID, the ID will determine which one to execute, right? So ID 0 is going to execute this. Execute with this data here. This data actually, this is not the data, this is a pointer pointing to the data. Okay, the data is here. It's a pointer, right? Because when I create the vector, with a type pointer. Okay, it's a pointer pointing to this node, this structure node. There's a string at the back node. Okay? So basically it's pointing here. Okay? So when I grab this content contains the address of this. Okay, this is the address that you pass into the process work. And then it will do the process. Okay, so that is the first way. The one that I showed you is the first way. Second way, you can try on your own using for loop. Alright, you don't need the vector. Alright, and everybody needs to access into this linked list, and you will never be any race condition, because you're only reading. You're not changing anything inside this linked list, so there will be no race condition. Everybody is reading. Okay, so everybody can enter at the same time and then travel inside this or traverse this linked list. So you traverse and then you go and grab this only element. Okay, ID 0 is going to grab this. ID 1 is going to grab this. 2 is going to grab this. 3 is going to grab that. 4 is going to grab that. 5, because it's seen now, so you get out. And then because it's now, it's not going to process, so you just don't do anything. 6, 7, 8, 9, 10 until 16, you will skip all this, including this one as well. So you just don't do anything. Only the first 5 is going to process it, and eventually, when you're done, you'll get out. Okay, you'll get out. You stop the time. You record the time. And then the master thread is going to print out the data. Okay, so the data will be inside there already. Will be nicely inside there. Okay, so when you print out all the Fibonacci number. Okay, so I already give you the solution for the first way, that one, using vector. Okay, if you are interested to try the second way, you can try on the one. I will not give you any code guidance there, but I already give you some hint how to do this. Alright. Now here, because I don't use any scheduling type, so it's going to be default. I think it's going to be static or runtime. I do not know. Okay. Later on, you can come back again and then try to change the scheduler to a different scheduler. Okay. But to solve this, actually, scheduler will not solve it. Scheduler is just schedule how your thread is going to run. But this is one of the way to do your or to solve your problem. Okay, this is another way. Okay, okay, try that. I already give you the solution here. You just need to wait and then call it, and then you should get the answer. It's only 2 lines, 1 line here, 1 line. Okay, there's no private there. There's no private. Everything by default is shut. Okay, so this. So yeah, we're doing parallel 4. Just going to parallel. the answer here. Okay, I use the second way to solve the problem. I showed you the first way just now. Okay, but I use the second way to solve it. So I got the answer there. Okay, here the scheduler type is the default scheduler type, so you can try any other scheduler type. I'm not sure whether you can see any difference there or not. Well, most probably you won't see any difference. Maybe the time will be faster. Okay? The time can be faster, it depends. Okay, in my case here, I already solved. You can see that number there is the same. Is it the same? Verify whether it's right or not. Okay, so we need to verify. Because you cannot just assume that your answer is correct, so I need to verify. So 38 is 39, they're the same. This one also the same. This one also the same. This one is the same. This also the same. This one also the same. So there are 5 altogether. 1, 2, 3, 4. Oh, there are 6. Sorry, there are 6, not 5. 6. I draw that 5. There's supposed to be 6. What time is 6? But n is 5. N is 5. Maybe including the 5. I'm not sure. I have to check the code again. Okay? So my code will just travel. Okay? And when it reaches now, it will skip this, and then it will also skip this. Okay? And if I have more threads, that means more than 6, it will skip this, sorry, it doesn't skip this, it will do it for loop. But when it reaches the now, it will just get out. Okay, it will get out. And then when you check, it is now, it will not process it. It will skip. So that's what my code did. And it discovered that there are 6 altogether. All the time I thought it was 5, but actually it looks like it was 6. Okay, and the time that is taken on my machine is about 5 seconds. Okay, I use the second way. I showed you just now, it's the first way. Okay, I did not try the first way, but you can try, let me know whether it works or not. I think it should work. This way also work, this way also work. Okay, you get the answer there. Try to find out whether the second way is faster or the first way is faster. I think more or less the same. The time more or less the same. Okay, about 5 seconds. Okay, anybody has tried the first way? Anyone? Got it? Got it? Oh, because P needs to be private. P needs to be private. Yeah, it takes 5 seconds to do it. No, actually it was here, sorry. Oh, I understand. Okay, okay, somebody did quite, quite good because at least you know that it must be private, but you made a mistake there. This one. This one I showed you here, right? So somebody, some friend, must have known that this must be, P must be private, right? Okay, but she used private only. What is going to happen if you use private only? That means that one is global. Like, sorry, that one is shared, right? P is shared. And then you create another private, so there are 2 copies there. And that P actually contains the head. And the P inside here, the private, will contain the head or not? Because you only put as private P. Will it be initialized? Outside there's a P, right? Inside there's another private P. But the P, is it initialized? No, so you have to initialize it. How do you initialize? How do you initialize? No, this one. How do you initialize it? Remember last week we were talking about this. First private and last private, remember? No. Yeah, private. It should be. Is it first private or last private? If you want to initialize, should it be first private or last private?
First.
Yeah, first private. Okay, if you put first private, then you will solve the problem. I mean, you will not have the error. Okay, so that is done. No, you cannot have a capital F. Small F. So done already. You have okay, barrier. Now here. Oh, sorry. What is a folder there? No, there's only one. Each track, okay, here, when you reach here, you do too complex already. Okay, when you enter into this parallel code, right? Every thread is going to run this. Okay, every thread is going to run. And every thread is going to enter into this and then find, sorry, doesn't do that. Every thread is going to wait here, right? And then here, when you reach here, the thread is only concerned about itself. It doesn't need to concern about the rest. Yours, you do everything, which is not right. The thread is only concerned of itself. So it's going to only use its own ID to grab this pointer here and then pass it to the process group. It's very simple. In fact, I already put the answer there. I already put the answer there. You do it too complex. Just a P. Sorry, not the P, sorry. There. I already put that. Number 4. Am I right? You put in the Fibonacci factor. This is the Fibonacci factor. And then you use the ID to access into the data. And then you grab the data and pass it to the processor. Got it? Now we can compare whether the first way or the second way is faster. I've done the second way. If you want to try your second way yourself, you can try it. But I've done it. But I want to see your first way because I haven't tried the first way. Does it work? No, here it shouldn't be so complex. Don't put for loop because every thread is going to do this. Each thread is only concerned about itself. Right? In your case here, you make every thread to do all this. No. Why would you do that? The thread is going to do its own one. Understand? So it should be very simple. Yours is for loop. You don't need all this for loop.
So just like it.
It should be very simple.
Like it.
Yeah, just like that. Hey, how come there's a for there? No. There's no need for loop there. There's no for loop there. Here I don't use any OMP parallel for. Okay, there's no for loop. There's only one loop there. That's all. There's only one loop. That loop is actually to convert this into this. And then down below, I can use this vector easily by accessing into the element. Okay? Try that and see what happens. Do you get it? Do you get the answer? Double check. Double check with the answer. Okay, how do you double check? Yeah. Go to this. How do I search it? Let's search it this way. I put Fibonacci predicate. And And then you scroll down below that, you see University of Wisconsin. Fibonacci number will tell us. Okay, it is from here to here. Right? I see that you. Is it the same? It's all the same. Is it 6 altogether? Okay, so the second way also work. Sorry, the first way also work. I see that there's an answer already. Okay, my one, I use the second way. Okay, I got the answer. The first way also we got the answer. It's also 6 Fibonacci, right? Do you understand how it works now? I know that I give you all the answer. Here I just ask you to fill in the blank. But you need to understand what is going on here. Because otherwise, how are you going to write the program? Right? You got it right now? You're almost there already. Still cannot. Why? You're almost there already. Oh yeah, sorry, I missed one more thing. Okay. Sorry, I made a mistake here. Okay, I think I'm not sure whether you noticed or not. Yeah, sorry about that. I missed one more thing. Okay, here you have to do like this. Here, if your ID is less or equals to the size, empty get track, get number of tracks. Okay, then only do this. Sorry, I missed just now. I missed this. Okay, otherwise you get the error. Okay. You need to put this. Because why? This is the same as avoiding this. There's an if here, right? So in second way, I avoid it this way. In the first way, you have to avoid it this way. Oh, sorry. This is a function, so I need to put back here like this. Okay? So I get the number of threads, how many threads? And then if the ID is, oh sorry. Not the ID, sorry. Sorry. This one should be Fibonacci size, sorry. Not the size. Yeah, it should be like this. Okay, I get the size. The size here, let's say, is 6, right? It's going to be 1, 2, 3, 4, 5, 6. So, sorry, this one needs to be this one. Okay? So, Fibonacci vector will be 6, it will return 6. And then my ID is 0 to 5 only. 0 to 5 will do it. The rest will skip it. So, it's the same as the second way. This is how I skip it. Right? In here, this is how we skip it. Okay? We find out what is the size here, how many elements in there. Right? Once we found the element already, then we check the ID. Because when I instantiate the threads, I might have 16 threads. But only the first 6 threads is going to do it. The rest of the thread is going to skip. Right now, you get the answer? Still. One minute.
考到有啊，它是什么？不是，它是考到。 我配上一个，就是好奇怪，他这个是在做什么不太懂。其实我也不懂。跟你讲那个跑来跑去，这样打人是在干嘛？在做什么工作？上网在查的，我就是也是算的，跟他这个university的答案都有部分的其他东西。F43，对，那这个东西是什么 ？F 是什么？第38在那里，就是等你跑出来，你答案要跟他一样，因为我们是从38开始。beginning with 走，然后看答案，从这里到。好像是在拿这里的资料过去的。是啊，不是对，还是算到他那个地方。
Percentage D, and then backslash F, comma, backslash F. No, this backslash F must be inside the data. After the volume. Do like this. If you want to debug, you can always check because I do not know why it returns now. So you want to check, you can always do it. So for I in maybe this one you just put auto, maybe P, or maybe anything. B maybe. In 509 factor because it's an object, and I can just use this. Get auto here means anytime. Okay, so I want to print out the number. So print F. Maybe here I want to print the ID first. Okay. And then I want to print out the data. Okay, and I'm passing. Sorry, I don't need this. I just need this. V data. Okay. So if I run the program, actually I don't have the code inside there. It's fine. This one is version 1. So I go down to version 1. Okay, I want to see what is inside there. Okay, when you run, you should get something printed out. Nothing there. Oh, yeah, sorry. remove this one. No wonder there's a process there. Remove this. Remove this. No wonder it crashed. In your case, you have that as well, right? So this one needs to be removed. Sorry about it. Okay. Okay, I made a mistake here. This one should be like this. This one should be at the bottom, sorry. Move this one to the bottom. Because I can see the problem there. Okay, I push it first, then the next. Yeah, right, that's correct. Okay. So do this, remove this one. Just now I put the reverse. I should put this one. Push back first, then only go to the next one. Okay? Now this one is just to print out if to check the data, whether it's correct. Okay? Good. So remove this. And when it print out, it should print out this way. It should print out this one. So the first one is 38, 39, 40, 41, 42, 43, there are 6 over there. Okay, ignore this one because I don't have to go. It does not print out properly. So this one actually is printed out like this. Okay, from printing here, I can see what is wrong. Okay, so when you debug, give yourself some kind of a way to actually view your data. So when I view the data, I know what my problem was. Okay, so viewing your data is important. So by viewing the data, I know that I have switched the position. Is it correct right now? Did you get an answer? Yeah. So right now you can go back here, remove that, remove this. Okay, and then you can run. You should get the answer right. Yes. Run. Okay, take 5 seconds. You didn't print. Okay, you didn't print. Print down the two. Oh, this one you go there. Where you go and remove it? Hey, this one you go and delete it. No, 8 equals to T. The other area. You go and delete, or you delete this one. Now you print out. Is it correct now? Okay, I've got 2% already working. How about you? Got it? Got it working or not? Maybe you help him. Go ahead. Smiling, right? Smiling, right? This one changed. Yeah, I already changed. Change the position. This one cannot work because I refer to the audio program. Okay, the first part, just need to copy it. Push back first. Okay, push back means put to the back there. you get the answer. Infinite loop.
Open MP.
No, it takes 5 seconds to complete it. Take 5 more. No, there's more. Why you go first in print here? Yeah, this is.
差不多，跟韩国一样在上面。
哦，这是 P。P。
这里。上面。
Each one of them needs to have this.
已经。那什么是
So each one of them is going to travel.
control？ 压这个。
No. You have to create your own one. P.
那什么可以用完？
Okay, this P you cannot share. If you share, then you will get into a different loop. Why? Because you have race condition. Because you see, P is overwritten, right? So you have to make it private, right? Because everybody who enter into this code, okay, if you have only one P, then everybody is going to write into this P as they travel. And you know that when you write into the P, you will have race condition because you are sharing the P. Okay? So everybody needs to have his own P so that they can travel inside this limit. Alright? And then you need to initialize the P to hit. Okay? You need to have your own P and you need to initialize the P to hit. Start from there. Okay, you cannot start anywhere, you have to start from there. Right. Right, it scared me seeing your code. Oh, really? You can answer.
这里它是这个 M 的一 P data， 所以选 P was 那我们已经可以到 P 啊。
Try to solve. I will show you the.
刚好也是有出这个问题啊，是该怎么解决啊？该是有出这个问题了。哦 ，except improve 应该还是。
Use the first way. If you want to check the answer, sorry, you not check the answer. If let's say anything goes wrong, you want to check what you push into this vector, you can print it out. Okay? So I'll show you how to print out. Print out the debug your own code. Okay? Down below, you have to use the barrier, and there's some more changes that I made here. Okay, the change here is to make sure that your ID must be less than the size of this vector. Okay? If this vector is 6, here is 5. If it is 6, if the ID exceeds that, then it will not do anything. Okay, if the ID is within this size, then you have to grab this and then process. Okay? So here you're going to process 4, which is there. I already give you the answer. Okay? Try that. Yeah, 20. Language. Yes. You have to enable the web. If you don't enable, you won't be able to run in parallel. Follow. Then I will check.
哎，我要讲，主要该看那个 OpenIP。
Here's a nice code. The while loop.
The source file is different from
Yeah,
the
I push
module
first, then only I move to the next.
还是有发音有关系。 是吧？在零
The
零
original
八
book
年。
is you move the next one first, then only you push, right? So I think it's mistake that push, right? And then there's no When you do the process code in the if statement, down below, that one is for you to fill.
好，现在时间到了。什么都不懂，时间到。
还没给呢，还没给呢。
Then down below here, what do you
Sound
put?
like sure.
Actually, you should figure out yourself. And
他们是 last
I'll
minute。
give you the answer or report the answer is here. I just want to allow you to do on your own first. If you don't know, I already give you an answer. Go ahead. Right? You work on your resume. Where you want to go? You said already.
把电脑。
You better get a good degree first. You worry about internship already now. When are you going for internship? You got time. Good time. Correct.
真是有点早。
快走，人家还有面试东西。
12完了现在，那这几个 assignment 还会白皮交。他有什么东西要做嘛？其实他那个 video 只有没有看，那我没有进来。第一个礼拜讲嘛，就是要去开那个 account 嘛，开 account 就可以开始找。
Actually, I want you to figure out yourself, but I also put the answer here. See this answer here? It's supposed to be here. Assumption maybe you already exceeded. Okay. P cover, you make a copy. Will it initialize? Initialize with this residue?
因为我们两个是没有分。
No, no. How will you initialize to the P is private. Two different copies. This one will initialize to the other. Yes. Create another copy with the same name, but this one initialized to the value that is this one is holding. How do you do that? How do you do that? So that it's a private and also initialize the value. Should be.
这个是就200 P
啊？啊，
但是你讲那个第二，然后下个是就决定的话就是到7月的时候就一个 long day 一个 short day。
First private. Try again.
Again, what?
Repeat. Stop and then you enable your own copy. Enable your own copy, yes, but you-
然后后面就是这个是决定的别的。应该不是全部哦，我们全部都是保学上，不是保学上。
哦，讽刺。
我们3年。不过我跟我还有人，因为我很多课还没 pass，我还有7课还没 pass。
我是 outstanding，就是因为他这个要收费 pass 才可以考这2个课嘛，然后我那时候收费没有 pass，所以我就不能拿后面这一科，我全部不能拿。对，这我第一轮都没有拿过。因为那时候要收费你才有 pass 我这个也是。就是我没过。
Previous so what is the previous project? Practical side
IT 的工作做你的完东西。
finish it, right?
给公司。
You're supposed to do yourself, if you can try this on your own. There's another company this question.
是做什么方面？QA 我是很多科没有够我还7科。
try 应用，修这个
薪水我骗
下
了
争议，下争议，边疆啊，刚微送，刚刚的是莫威利，Jackson，永进，老永进
3倍2倍啊。
Asian High，New Vision，林家义，林桂汉，春后，
录音间是我
I saw your name just now. Your internship.
我那个时候可以像
But you work
因为我是口碑3，我在想真的看做那个这样的口碑。
当升级，当会员，当公药，我心意，心意条，一张卷。
他有做的别的。在这个队里面打算准备几个。
Okay, try the second way if you want to. You should get the answer, the same answer.
这个我可以换。
这个
这个我可以换。
差不多。
感觉不太行。不太行。
我感觉读过那么多课，这个是他的最分。
是比较 OK 的。
上次你是知道，上次是知道。
我的军队我知道。我的别的是上面手机的那个。
Okay, go now.
那个车。
Okay.
在讲开心一样。
在塞，大家好兴奋。